Assalamu alaikum, brothers and sisters. Welcome to the journey of Quest, where we quench your thirst of knowledge. Have you ever wondered how scientists study the Earth's surface from space? Or how they measure the movement of tectonic plates, the growth of cities, or the erosion of coastlines? The answer lies in remote sensing, a technology that uses satellites to collect data about our planet. However, managing and interpreting this data can pose a significant challenge. Enter COSI-Corr, a powerful tool that can simplify these tasks. The COSI-Corr software, developed by the French Institute of Earth Sciences, is specifically designed for remote sensing. It allows us to correlate images of the Earth's surface taken at different times, helping us to understand the changes that have occurred. But how does one install and run this software? Well, it's easier than you might think. To begin with, you need a functioning computer with a Windows operating system. The first step is to download the COSI-Corr software from its official website. Once the download is complete, extract the files using an extraction tool. Now, navigate to the folder where you've extracted the files and locate the installer. Double-click on it to commence the installation process. Follow the prompts on your screen, accepting the terms and conditions, and choosing the destination folder for the software. Once the installation is complete, the next step is to run the software. Locate the COSI-Corr icon on your desktop or in the destination folder you chose during the installation. Double-click on the icon to launch the software. The user interface is pretty straightforward, with menus and icons that guide you through the process of importing, correlating, and analyzing your remote sensing data. To import data, navigate to the File menu and select Open. You can then browse your computer for the data file you wish to analyze. Once your data is imported, you can use the various tools and features of COSI-Corr to correlate and analyze it. The software allows you to overlay images, adjust their alignment, and even calculate the displacement between them. In the course of this video, we've uncovered the challenges of remote sensing and how COSI-Corr can help overcome them. We've walked through the process of installing and running this powerful software, breaking it down into easy-to-understand steps. In summary, COSI-Corr is a robust tool that simplifies the interpretation of remote sensing data. Its installation and operation are straightforward, making it accessible to anyone interested in studying the Earth's surface. Indeed, understanding our planet has never been easier, thanks to the remarkable capabilities of COSI-Corr. So why not give it a try today? It's time to unlock a whole new perspective of our ever-changing world. In this segment, we will dive deeper into one of COSI-Corr's key features, the displacement calculation tool. This feature is designed to calculate the displacement between two images, providing valuable information about the changes in the Earth's surface over time. To use this feature, simply select the Tools menu, then Displacement Calculation. You'll need to input two images, preferably of the same area but taken at different times. After setting your parameters, hit Calculate. COSI-Corr will then generate a result that shows the displacement of the area in question. To illustrate the practical application of this feature, let's consider a real-world case study. We will analyze satellite images of a glacier in the Arctic region, taken 10 years apart. By using the displacement calculation tool, we can observe the significant reduction in the glacier's size over the decade. This provides a stark and quantifiable visual representation of the effects of global warming. This case study is just one example of how COSI-Corr's features can be used to study and understand the changes happening on our planet. By using COSI-Corr, we can make these changes visible, measurable, and most importantly, impossible to ignore. Remember, COSI-Corr is an incredibly powerful tool, but it's only as good as the data you feed into it. So always ensure that you're using high-quality, accurate data for your analyses. Stay tuned for our next segment, where we will wrap up this tutorial. In this segment, we'll take you through the enhanced analysis feature of COSI-Corr. This tool allows users to perform a more detailed inspection of the displacement data that we calculated in the previous segment. To access this feature, navigate to the Tools menu and select Enhanced Analysis. Here, you can input the displacement data file generated by the displacement calculation tool, and COSI-Corr will generate a more detailed image, highlighting the areas of greatest change. Let's apply this to our case study from the previous segment. By using the Enhanced Analysis tool on our Arctic glacier displacement data, we can clearly see the areas of the glacier that have experienced the most significant size reduction. This provides a more detailed understanding of the glacier's retreat pattern over the past decade. In addition to visualizing the displacement data, this tool also provides useful statistics about the changes. For instance, it can show the average rate of displacement over the specified period, the total area affected, and even predict future changes based on the current rate of displacement. The enhanced analysis feature is just another example of how COSI-Corr can transform raw data into meaningful insights about our planet's changing landscapes. Remember, the power of COSI-Corr lies not just in its ability to calculate and visualize data, but also in the insights that this data can provide. In the next segment, we will wrap up this tutorial, summarizing what we've learned and how you can apply these tools in your own research. Stay tuned. In this segment, we'll delve deeper into one of the most powerful features of COSI-Corr, the predictive analysis tool. This tool takes the displacement data we've been working with and uses it to predict future changes in the landscape. To activate it, go to the Tools menu and select Predictive Analysis. Here, you'll need to input the displacement data file generated earlier. Once done, COSI-Corr will generate a predictive model showing the potential changes in the studied area over the specified future period. Now let's apply this to a case study. We'll use the Arctic glacier data from our previous segments. By feeding our displacement data into the predictive analysis tool, we can project the future retreat patterns of the glacier over the next decade. The generated model provides a clear visual representation of the areas that are predicted to experience the most significant changes. This is invaluable information for scientists and conservationists who are working to understand and mitigate the impacts of climate change. This tool also provides statistical predictions, such as the anticipated average rate of displacement and the predicted total area affected. These statistics can be used to inform strategies for climate change mitigation, as well as provide valuable data for scientific research. In this segment, we will further explore COSI-Corr's time series analysis feature, another powerful tool that allows scientists to observe changes in the landscape over a specific period. This feature is particularly useful when studying long-term changes in the environment, such as the gradual retreat of glaciers or the shift of tectonic plates. To activate the time series analysis, navigate to the Tools menu and select Time Series Analysis. Here, you'll need to input a series of displacement data files, each corresponding to a different point in time. Once you've input all the necessary data, COSI-Corr will generate a time series model that visualizes the changes in the studied area over the specified period. Now let's see this tool in action through a case study. We'll return to our Arctic glacier data and input the displacement data from different years. The generated time series model beautifully illustrates the glacier's retreat over time, providing a stark visual testament to the impacts of climate change. The time series analysis also provides quantifiable data, such as the rate of change over time and the total area affected. This data can help scientists to understand the pace of environmental changes, inform climate change mitigation strategies, and contribute to scientific research. Stay tuned, as in our next segment, we'll be diving into the practical applications of these tools and how they can be used in real-world scenarios. In this segment, we will be honing in on another fascinating feature of the COSI-Corr software, displacement mapping. This unique feature aids in visualizing and understanding the physical displacement of geographical features over time, offering a dynamic perspective of environmental change. To access the displacement mapping tool, head to the Tools section and select Displacement Mapping. You will need to provide two sets of data that represent the same geographical area, but at different points in time. Once the data is loaded, COSI-Corr will compare the two data sets and create a displacement map, effectively illustrating the changes that have occurred between the two time frames. To demonstrate the power of this tool, we will be turning to a case study involving the San Andreas Fault, a well-known tectonic boundary in California. By inputting data sets from 1980 and 2020, we can clearly see the shift in tectonic plates over this 40-year period. The displacement map, created by COSI-Corr, not only visually represents this shift, but also provides quantifiable data, such as the total distance of displacement, which is invaluable for geological studies. By using the displacement mapping tool, scientists can track and analyze the movement of geographical features over time, providing crucial insights into the dynamic nature of our planet. In the next segment, we will explore how these insights can be applied in real-world scenarios. So keep watching. In this section, we're going to delve into the practical implications of COSI-Corr's displacement mapping feature. The power of this tool extends well beyond the realms of academia and into various industries. Firstly, in the field of urban planning and development, displacement maps can provide invaluable data on the stability of the land. They can help identify areas prone to shifts, which is crucial when planning infrastructure projects. To illustrate this, let's look at our case study, the proposed railway line near the San Andreas Fault. By using the displacement map we created in the previous segment, urban planners were able to identify areas of significant tectonic activity. This data was instrumental in rerouting the railway line to avoid these unstable regions, thereby ensuring the long-term safety and viability of the project. Secondly, in environmental conservation efforts, displacement mapping can track changes in natural habitats over time. This can be used to monitor the impact of climate change and human activities on these ecosystems. For our case study, we will revisit the San Andreas Fault, but this time focusing on the migration of the desert tortoise, a species native to the area. By comparing displacement maps over several years, conservationists were able to observe changes in the tortoise's habitat. This information has been crucial in developing strategies to protect this endangered species. In conclusion, the displacement mapping tool, while technical in nature, has vast practical applications that can positively impact various sectors. In our next segment, we will dive into another feature of COSI-Corr, so stay tuned. In this segment, we're going to explore another impressive capability of COSI-Corr, the change detection feature. This tool allows users to identify and analyze changes in a landscape over a period of time. It's an invaluable resource for researchers and professionals across a range of disciplines, offering insights that can inform critical decision-making processes. To illustrate the power of this feature, let's dive into a fascinating case study, the retreating glaciers in the Himalayas. With the help of COSI-Corr's change detection tool, scientists were able to compare satellite images of the glaciers from different years. The software precisely highlighted the areas that had changed, providing a clear visualization of the extent and pace of glacial retreat due to global warming. The data generated by the change detection tool isn't just informative, it's actionable. In this case, it has been instrumental in raising awareness about the impact of climate change on these fragile ecosystems. Moreover, it has helped local communities and policymakers in the Himalayan region to understand the severity of the situation and develop strategies to mitigate the impact of glacial retreat. So as you can see, COSI-Corr's change detection tool is more than just a technical feature. It's a powerful instrument for change, providing vital data that can influence policy, drive action, and ultimately help safeguard our planet. In our next segment, we will continue to explore the practical applications of COSI-Corr's features, so stay tuned. In this segment, we're going to unveil yet another impactful feature of COSI-Corr, the image correlation tool. This fascinating feature enables users to compare two images and identify the areas of correlation and discrepancy between them. It's a powerful tool that can be applied in various fields, from geological research to urban planning. To help you fully grasp the potential of this tool, we're going to delve into a case study, the urban expansion of Las Vegas. Using COSI-Corr's image correlation tool, researchers were able to compare satellite images of Las Vegas from 1980 and 2020. The software accurately identified the areas of expansion, providing a clear visualization of the city's growth over 4 decades. This data is not just informative, it's actionable. In this case, it has been instrumental in understanding the urbanization patterns and planning for sustainable city development. The image correlation tool is thus not just a feature of the COSI-Corr software, it's a powerful tool that can aid in the sustainable development of our cities and contribute to a better future. Stick around for our next segment, where we will continue to explore the practical applications of COSI-Corr's features. Get ready to delve into another fascinating feature of COSI-Corr, the spectral analysis tool. This tool is equipped to help users analyze the spectral characteristics of a given area using multispectral images. This powerful feature can be used to identify and classify different land features based on their spectral signatures. To make this concept more tangible, we'll take a look at a case study: the environmental changes in the Amazon rainforest. With COSI-Corr's spectral analysis tool, environmental scientists were able to analyze the spectral signatures of different areas of the Amazon rainforest using satellite imagery. The software accurately differentiated between healthy vegetation, degraded areas, and deforested areas based on their unique spectral characteristics. This data has proven invaluable in monitoring environmental changes and assessing the impacts of human activities on this vital ecosystem. The spectral analysis tool thus goes beyond being a mere feature of the COSI-Corr software. It's a potent instrument that can aid in the preservation of our environment by providing critical data for conservation efforts. Stay tuned for our next segment, where we'll continue to explore the practical applications of COSI-Corr's features. In this next segment, we'll uncover another powerful tool in COSI-Corr's arsenal: the multi-temporal analysis feature. This tool enables users to analyze changes in a given area over different periods of time, providing a dynamic view of the area's evolution. Imagine having the ability to witness the progress of a city's development over several years, or observe the gradual impact of climate change on a particular ecosystem. With COSI-Corr's multi-temporal analysis, you can do just that. To illustrate the power of this tool, let's look at a case study: the rapid urbanization of Shanghai, China. Using a series of satellite images taken over a span of 20 years, the multi-temporal analysis tool allowed urban planners to visually trace the city's expansion and structural changes. This helped them identify patterns of urban development, areas of high growth, and regions that remained relatively unchanged. This data is not just a historical record, but a valuable resource for future urban planning. It aids in understanding the implications of past decisions and informs future ones, making the multi-temporal analysis tool a vital component of sustainable urban development. In the next scene, we'll see how all these features come together to make COSI-Corr a comprehensive tool for remote sensing analysis. Stay tuned. In this segment, we're going to bring together all the powerful features of COSI-Corr we've covered so far, demonstrating how they integrate to provide a comprehensive tool for remote sensing analysis. We will also present a case study that showcases how these tools can be used in concert to provide deeper insights. We will use the example of a recent environmental impact assessment conducted in the Amazon rainforest. The study used COSI-Corr's spectral analysis, image correlation, change detection, displacement mapping, and multi-temporal analysis features to monitor changes in the landscape over a period of 5 years. These features were used to detect deforestation, track the movement of rivers, identify changes in vegetation cover, and observe the impact of climate change. The multi-temporal analysis feature was particularly effective in demonstrating the speed and extent of deforestation. This comprehensive analysis provided invaluable data, helping environmentalists and policymakers to understand the scale of the impact and plan effective conservation strategies. With COSI-Corr, you're not just getting a series of separate tools, but an integrated system that offers a holistic view of your study area. Stay tuned for our final thoughts on why COSI-Corr is a must-have tool for anyone involved in remote sensing. In this segment, we're going to delve deeper into one of COSI-Corr's most powerful features: the advanced terrain analysis. This feature allows users to analyze complex terrain structures, detect subtle changes in the landscape, and predict future alterations based on current trends. To truly grasp the potential of this feature, let's examine a recent case study: the erosion monitoring in the Grand Canyon. This study deployed COSI-Corr's advanced terrain analysis to monitor changes in the canyon's structure over a decade. Using this feature, scientists were able to identify areas of rapid erosion, predict future vulnerable spots, and understand the underlying factors influencing these changes. The advanced terrain analysis allowed them to visualize the progression of erosion in a way that was not possible before, providing a clear picture of the changes happening in this iconic landmark. Visuals will be included to illustrate how the advanced terrain analysis feature is used, how it interprets data, and how it presents the findings in an easy-to-understand format. We will also show you the actual data from the Grand Canyon case study, so you can see firsthand how COSI-Corr's advanced terrain analysis can revolutionize the way we understand and interact with our planet's terrain. Stay tuned as we conclude our deep dive into COSI-Corr. and why it's an indispensable tool for anyone involved in remote sensing. As we continue our exploration of COSI-Corr's powerful features, we now turn our attention to the groundbreaking sub-pixel registration feature. This tool is a game changer in the world of remote sensing, providing users with an unparalleled level of detail and precision. The sub-pixel registration feature allows scientists to align images with sub-pixel accuracy, opening up a new realm of possibilities for detailed and accurate analysis. To illustrate the power of this feature, we will walk you through a fascinating case study, the monitoring of glacial movements in the Arctic region. Scientists utilized COSI-Corr's sub-pixel registration to track the movement of glaciers over time with an exceptional level of detail. This enabled them to identify subtle shifts in the glacier's positions and provided pivotal insights into the impacts of climate change on these crucial ecosystems. We will guide you through the process of employing the sub-pixel registration feature, demonstrating how to input data, adjust settings for optimum results, and interpret the output. We will also present visuals from the Arctic case study, allowing you to see the precision and detail that COSI-Corr's sub-pixel registration can provide. Stay tuned as we continue to explore the robust capabilities of COSI-Corr and how it is shaping the future of remote sensing. As we journey further into the vast capabilities of COSI-Corr, we now delve into one of its most intricate features, the deformation analysis. This feature is particularly crucial for studying Earth's dynamic processes that constantly reshape its surface, such as earthquakes, landslides, or volcanic activities. The deformation analysis feature allows users to measure and visualize the extent of these changes, providing valuable insights into the forces that shape our planet. In this scene, we will introduce you to the mechanics of the deformation analysis feature, guiding you on how to set parameters, interpret results, and utilize its potential to the fullest. We will then showcase a compelling case study, the analysis of the 2010 Haiti earthquake. By employing COSI-Corr's deformation analysis, scientists were able to quantify the devastating ground displacement caused by this catastrophic event, contributing significantly to our understanding of seismic activities and their impacts. We will display visuals from the Haiti case study, demonstrating how the deformation analysis feature enabled scientists to map the ground deformation in unprecedented detail. This example will illustrate the power and precision of COSI-Corr's deformation analysis feature and its critical role in studying our ever-changing Earth. Stay tuned as we continue to unravel the fascinating capabilities of COSI-Corr, your essential tool for comprehensive remote sensing analysis. As we continue our exploration of COSI-Corr's astounding capabilities, let's turn our attention to its surface rupture analysis feature. This innovative tool is vital for studying geological phenomena that lead to the rupture of the Earth's surface, such as earthquakes and volcanic eruptions. The surface rupture analysis feature measures and visualizes surface disruptions in high detail, offering researchers a clear understanding of the scale and direction of these earth-shattering events. In this scene, we will walk you through the operation of the surface rupture analysis feature, showing you how to set parameters, analyze results, and maximize its potential. Following that, we will present a captivating case study, the analysis of the 2018 Kilauea volcano eruption in Hawaii. Using COSI-Corr's surface rupture analysis, scientists were able to map the extensive lava flow and surface disruptions caused by this significant event, providing a deeper understanding of volcanic activities and their impacts. We will showcase visuals from the Kilauea case study, highlighting how the surface rupture analysis feature helps scientists to study the surface changes in unparalleled detail. This case study serves as a testament to the power and precision of COSI-Corr's surface rupture analysis feature and its critical role in studying our dynamic planet. As we move forward, we will continue to unveil the extraordinary capabilities of COSI-Corr, your indispensable tool for comprehensive remote sensing analysis. Stay tuned. As we delve deeper into the powerful features of COSI-Corr, we now shift our focus to its terrain change detection feature. This highly effective tool allows researchers to monitor and measure alterations in the Earth's surface over time, providing invaluable data for understanding natural phenomena and human-induced changes. The terrain change detection feature is capable of identifying subtle shifts in the terrain, capturing the dynamics of our ever-changing planet in high resolution. In this scene, we will guide you through the process of utilizing the terrain change detection feature, explaining how to input parameters, interpret results, and harness its full potential. To supplement this, we will present an intriguing case study: the analysis of the Aral Sea's shrinkage. The Aral Sea, once one of the 4 largest lakes in the world, has been steadily shrinking due to extensive water diversions for irrigation. Using COSI-Corr's terrain change detection, scientists have been able to map the drastic changes in the Aral Sea's size over the decades. We will share visuals from this case study, underlining how the terrain change detection feature enabled scientists to monitor the changes and understand the severity of the situation. This case study illustrates the importance of COSI-Corr's terrain change detection feature in studying environmental changes and their implications. As we progress, we will continue to uncover the remarkable functionalities of COSI-Corr, your ultimate companion for detailed and efficient remote sensing analysis. Stay tuned for more. As we continue to traverse the multifaceted functionalities of COSI-Corr, we now turn our attention to its land cover classification feature. This sophisticated feature enables the categorization of different types of land cover, such as forests, water bodies, urban areas, and agricultural fields, using satellite or aerial imagery. The land cover classification feature is indispensable for a range of applications, including environmental monitoring, land use planning, and disaster management. In this scene, we will walk you through the process of using the land cover classification feature, detailing how to select the appropriate parameters, interpret the classification results, and maximize its effectiveness. To bring this to life, we will introduce an engaging case study: the monitoring of deforestation in the Amazon rainforest. The Amazon rainforest, often referred to as the lungs of the earth, has been subjected to rampant deforestation due to logging, mining, and agricultural activities. Using the land cover classification feature of COSI-Corr, researchers have been able to map the extent of deforestation, providing crucial data for conservation efforts. We will share visuals from this case study, highlighting how the land cover classification feature made it possible for researchers to track the changes and understand the magnitude of the deforestation. This case study underlines the profound utility of COSI-Corr's land cover classification feature in studying environmental changes and aiding in conservation efforts. As we move forward, we will continue to reveal the impressive capabilities of COSI-Corr, your go-to tool for detailed and efficient remote sensing analysis. Stay tuned for more. As we journey deeper into the expansive functionalities of COSI-Corr, our next stop is the vegetation index analysis feature. This powerful tool allows us to quantify the concentration and health of vegetation in a specific area using spectral reflectance measurements captured in satellite or aerial images. The vegetation index analysis feature is crucial for a variety of applications, such as monitoring crop health, assessing drought conditions, and identifying areas of deforestation. In this scene, we will guide you through the process of using the vegetation index analysis feature, explaining how to select the suitable parameters, interpret the analysis results, and optimize its utility. To illustrate its application, we will delve into a compelling case study, monitoring the health of crops in the California Central Valley. The California Central Valley, known as the breadbasket of the world, is home to a significant portion of the United States agricultural output. Using COSI-Corr's vegetation index analysis, researchers were able to identify areas of crop stress early, enabling timely interventions to protect crop yield. We will share visuals from this case study, demonstrating how the vegetation index analysis feature empowered researchers to monitor crop health and take preventive measures. This case study underscores the enormous potential of COSI-Corr's vegetation index analysis feature in agricultural management and environmental conservation. As we continue to explore, we will unveil more remarkable capabilities of COSI-Corr, your ultimate tool for comprehensive and efficient remote sensing analysis. Stay tuned for more. Voiceover. As we continue to unlock the potential of COSI-Corr, let's now turn our attention to another significant feature, the soil moisture analysis. This powerful tool enables us to measure and track the moisture content in the soil using remote sensing data. Soil moisture is a critical variable in understanding the Earth's water cycle, predicting weather patterns, and managing water resources. The soil moisture analysis feature is thus essential for a diverse range of applications, from meteorology to agriculture, and from hydrology to climate change studies. In this scene, we will guide you through the process of using the soil moisture analysis feature, demonstrating how to select the appropriate parameters, interpret the analysis results, and maximize its usage. To illustrate its practical application, we will delve into a captivating case study predicting drought conditions in the Sahel region of Africa. The Sahel region, a semi-arid transition zone between the Sahara Desert and the Sudanian savanna, is highly vulnerable to variations in rainfall and drought conditions. Using COSI-Corr's soil moisture analysis, researchers were able to predict impending droughts, providing valuable lead time for the implementation of mitigation strategies. We will share visuals from this case study showing how the soil moisture analysis feature empowered researchers to understand the soil moisture dynamics and predict drought conditions. This case study highlights the enormous potential of COSI-Corr's soil moisture analysis feature in weather forecasting, drought prediction, and water resource management. As we delve deeper into the capabilities of COSI-Corr, we will uncover more impressive features that make it an indispensable tool for comprehensive and efficient remote sensing analysis. Stay tuned for more voiceover. As we journey further into the capabilities of COSI-Corr, our next stop is the atmospheric correction feature. This sophisticated feature is designed to adjust the satellite imagery data for atmospheric conditions. By doing so, it ensures a more accurate and precise interpretation of the Earth's surface. The atmospheric correction feature is particularly crucial in remote sensing, as it helps eliminate the distortions and noise caused by the atmosphere, such as haze, dust, or even cloud cover. In this scene, we will walk you through the nuts and bolts of the atmospheric correction feature, explaining how to apply it and interpret its results. We will also demonstrate its practical application through an intriguing case study, monitoring air pollution levels in Beijing, China. Beijing, known for its severe air pollution issues, has been the focus of several atmospheric studies. Using COSI-Corr's atmospheric correction feature, researchers were able to accurately assess the pollution levels by removing atmospheric interferences from the satellite images. We will share visuals from this case study, showing how the atmospheric correction feature helped to reveal the true extent of air pollution in Beijing. This case study underscores the immense potential of COSI-Corr's atmospheric correction feature in environmental monitoring and pollution control. As we continue to explore the advanced features of COSI-Corr, you'll discover why it stands as an unrivaled tool in the world of remote sensing analysis. So, stay tuned as we delve deeper into this fascinating world. Thanks for watching us share our videos. Subscribe our YouTube channel and press the bell icon and stay curious for new uploads.